All right, this topic is on rate of change and slope. So let's define what rate of change is first. So rate of change shows the relationship between two changing quantities. When one quantity depends on the other, the following is true. So if you have two quantities that are changing in value and one of them depends upon the other one, then this will be how you find the rate of change. And it's the change in the dependent variable y over the change in the independent variable x. All right, so let's look at some examples of that. So the table shows the distance a band marches over time. Is the rate of change in distance with respect to the time constant? What does the rate of change represent? So first of all, you need to figure out what's your dependent and what's your independent variable. So first off, time is always an independent variable. So time is always independent. And the way that I think of that, so independent, the way that I remember that is time doesn't depend on anything. Time is just going to happen. But the distance here, the distance that the band marches, is dependent upon the time, right? The more time, the further they're going to march. So the distance is the dependent variable. Dependent. Dependent. I feel like I'm missing letters there. Hopefully not. In algebra, we typically define the dependent variable, excuse me, as our y variable, and the independent variable as our x variable. All right, so the rate of change is the change in the y value over the change in the x value. And so they wanted us to see if this has a constant rate of change. And so I'm just going to check the rate of change through this table. So I'm going to do uh, this change over this change, right? So that would be 520 minus 260 over 1. And so that's equal to 260 feet per minute. All right, let's go to the next step. So this one I've got, the change is 780 minus 520, again over 1, and that's 260 over 1. So far it's constant. And then the last step here, I've got 1040 over 1, sorry, 1040 minus 780, forgot that piece, over 1. And that also comes out to 260 over 1. So it is a constant rate of change. All right, now I just want to show you, I did it step by step like this, right? If there's a constant rate of change here, then watch this. I can also look at the change between any two steps here. So I can look at this change if I want over this change, and it should come out to 260 over 1. So this change from 260 to 1040, right? So take 1040 over 260. Sorry, 1040. My mind is thinking about something else. I apologize. Let me focus on what I'm doing. So 1040 minus 260. So that's the change in the dependent variable over the change in the independent variable, which is 4 minus 1. So that comes out to, let's see, that would be 740 plus 40. That would be 780 over 3, which simplifies to 260 over 1. So I can do the difference, the change between any two steps here, and it should come out to 260 feet per minute. And as far as what this constant rate tells us, it tells us that the band marches 260 feet every minute. All right. Now, rate of change has another name. It is also called slope. So slope is the same thing as rate of change. Slope, we're usually talking about something on a graph, but not necessarily. Okay, so just know that slope and rate of change are really the same thing. So I'm going to show you how to find what's called the slope on a graph. And so slope is the vertical change over the horizontal change, which is really the same thing here. The change in the dependent variable. This is my dependent variable right here, distance. Notice this is a graph of this data, okay? So I showed you how to find the rate of change from the graph. Now I'm going to show you how to find the rate of change. Or sorry, I showed you how to find the rate of change from the table. Now I'm going to show you how to find it from the graph. So here's my dependent variable. Here's my independent variable. Time will always be an independent variable. Independent. And so if I want to find the change in my dependent variable, I wrote distance up here and I remember dependent. This is what happens when I record these first thing in the morning before I've had coffee. So the change in my dependent variable is a vertical change. The change in my independent variable is a horizontal change. So just like over here, I could do the change between any of these segments and they would all come out the same. So the same is true here. So pick 2 points on the graph. And so we're going to pick this point here and this point here. And the vertical change is 260. So this point here represents the, let's see, the 520. So it went from 520 up to 780. So that's a change of 260. And then the horizontal change is it went from 2 to 3. So that's a change of 1. So it went up 260. We call this rise. And it went over 1. So from one point to the next, we went up 260 and over 1. So it's a rise of 260 and a run of 1. So the easiest way to remember this is to remember this saying here, rise over run. So to find the slope, pick 2 points, see how far you have to rise, and see how far you have to run. And that will give you the slope, which is also known as the rate of change. All right, so let's look at a couple more examples of this. All right, what is the slope of each line in parts A and B? So here's my 2 points. So again, what I'm going to do here, slope is equal to the rise over the run. So for this one, I go up 1, 2. So the rise is 2. And the run, 1, 2, 3, 4, 5. So my slope is 2/5. Okay, so from one point to the next, do rise over run. Simple. All right, now let's look at the next one. So again, I'm going to do rise over run. So I rise 2 and run 1, 2, 3, 4, 5, 6. So this one is 2 over 6. And you should always simplify fractions. So this one simplifies to 1/3. All right, now here's something I'm going to ask you to memorize. If a line is leaning to the right, like A, this is a positive slope. If a line is leaning to the left, like B, this is a negative slope. And I'm just going to ask that you memorize that. A line leaning to the right is a positive slope. A line leaning to the left is a negative slope. So that means the slope down here is actually negative 1/3. So you just have to remember that. So you do the rise over run, the same for both of them. But if the line's leaning to the left, put a negative slope. If the line's leaning to the right, put a positive slope. All right. So I showed you how to find the rate of change or the slope from a table and then from a graph. And now I'm going to show you, well, what if they just give you the coordinates of 2 points? All right. So here's the formula. Unfortunately, this is something that you need to memorize. So remember, the rise is the vertical change. So that's the change in your y value. So if you think about coordinate plane, this is x-axis, this is y. So change in y is a vertical change. The change in x is a horizontal change. So here's my best piece of advice on doing these. This is saying the change in the two y values. This is y value number 1, y value number 2, and the change in the x values, x value number 1, x value number 2. To make sure you don't get confused on what to plug in where, the first thing you should do is label these points. So I'm just going to call this one x1 and this one y1, and I'm going to call this x2 and y2. So once I've labeled those, then I can just simply plug that into the formula. So again, the formula is slope equals y2 minus y1 over x2 minus x1. Now, I could have labeled this one x2, y2, and this one x1, y1. It wouldn't matter. So it's your choice. Okay? What you can't do is you can't label this point x1 and this point y2. Don't do that. So it's x1, y1, and then x2, y2. So now we just plug in those values. So y2 is negative 2 minus y1, which is 0. x2 is 3 minus x1, which is negative 1. So just do this math. Negative 2 minus 0 is negative 2. 3 minus negative 1, that's the same thing as 3 plus 1, so that's 4. And then simplify that to negative 1/2. Now keep in mind, since this has a negative slope, it's a line leaning to the left, like that. Okay? All right, so same thing on this next one. I'm going to start off by labeling these x1, y1, x2, y2. Most common mistake is people not doing this step and then getting confused when they plug in the numbers and they don't plug them in the right. So the slope, again, is equal to y2 minus y1 over x2 minus x1. So that's 2 minus negative 3 over 4 minus 4. 2 minus negative 3, that's the same thing as 2 plus 3, so that's 5. 4 minus 4 is 0. You can never have 0 in the denominator of a fraction. So the answer to this is this symbol, which means undefined. The slope is undefined. And I'm going to explain to you in a little bit what that line would look like on a graph. All right. And then one more here. So again, I'm going to label these x1, y1, x2, y2. So the slope, y2 minus y1, so that's negative 3 minus negative 3 over 5 minus negative 1. And negative 3 minus negative 3, that's the same thing as negative 3 plus 3. That's 0 over 6. You can have a 0 in the denominator, in the numerator. So 0 divided by 6 is just equal to 0. So the slope of this one is 0. So if the 0 is in the denominator, it's undefined. If the 0 is in the numerator, then the slope is just 0. And I'm going to show you what the graphs of those two look like here in just a second. All right. So finding the slopes of horizontal and vertical lines. All right. So if you think of rise over run, rise over run, that's what slope is, right? So from this point to this point, the rise is 0, right? It doesn't go up at all or down. And the run is 1, 2, 3, 4, 5. And 0 over 5 simplifies to 0. The slope of a horizontal line is always 0. So here's how I think of this. I should have mentioned this earlier. Slope kind of measures the steepness of a line, how steep it is. A flat line, a horizontal line, has no steepness at all, so it has a slope of 0. All right, now look at this one. On this one, the rise is 1, 2, 3, and the run, it doesn't go left or right, so the run is 0. So this one is undefined. So a vertical line, the slope is always undefined. And this might seem silly, but the way I remember this is I think, okay, if I tried to measure how steep this was, it's so steep I would just fall off and I wouldn't be able to measure it. If you think of it like a hill or something. I don't know. It's kind of silly. That's how I remember it. So horizontal line has no steepness. The slope is 0. A vertical line has lots of steepness and it's undefined. So, all right. So here's just a quick summary for you. So I'll let you read over this. It kind of explains all the things that we did. A line with a positive slope leans to the right. A line with a negative slope leans to the left. A line with a 0 slope is horizontal, and an undefined slope is vertical. All right. So I hope that was helpful to you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.